Hey, glad you're here for the 5.12 help video. Okay, so before you take this quiz, here's what you need to remember. The perpendicular bisectors create the circumcenter. The angle bisectors create the incenter. And the circumcenter is the center of the circle that goes on the outside of the triangle through the vertices. Whereas the incenter is the center of the circle where the circle is inside the triangle, touching each side. Alright, and I have a hard time with memorizing things, so I remember this little rap, and it starts off by saying, people be crazy, a bit insane. And that helps me remember that people be crazy reminds me that the perpendicular bisectors create the circumcenter. And then a bit insane reminds me that the angle bisectors create the incenter. Alright, so that's just some stuff to recall. Let's look at the first type quiz question. Where is the circumcenter of this acute triangle located? Well, y'all, the circumcenter in an acute triangle is always going to be inside the triangle. And you can refer back to your foldable note for that one. Alright, so on this one, it tells us that they're perpendicular bisectors. And then it says BE is 3. Let me just label these as we go. So BE is 3. GE is 4. And we want to know the length of AG. Okay, so this might be a little mind-blowing, but let me start off by saying, let me copy this over here. Can't copy that. Okay, I had to copy this picture in here because I really want you to see this. Now remember, the circumcenter is created by those perpendicular bisectors, and it creates this circle that goes through each vertice. Now what that tells us is that from the circumcenter to the vertex is the radius of the circle. And we know that in circles, all the radii have to be the same length. That's what it means to be a circle. So if we look here, let me go back up to our picture that we're given. BG is going to be a radius of that circumscribed circle, as well as AG and GC. All of those are going to be radii of that circle. So all three of those green lines are going to be the exact same length. Okay, so why did I waste our time telling us that? How does that help us? Well, the reason that helps us is because we can create this right triangle here, this red right triangle, and find the side length of BG. And once I find BG, I know that that's going to be the same as AG and the same as GC. So since my goal here is to find AG, that's not part of my triangle. So I need to use the triangle to find BG and then just say that it's equal. Okay, so in a right triangle, you can use Pythagorean theorem. A squared plus B squared equals C squared. So 3 squared plus 4 squared equals C squared. 9 plus 16 equals C squared, then add those together. And then finally, to get rid of a square, you would square root, because squares and square roots are opposites. So we did all that to find the length of BG. The BG is 5, but that means AG is also 5, again, because those are radii of the circumscribed circle. So our answer here is 5. Alright, so the next one says, what are the coordinates of the circumcenter of the triangle? Well, this is where you have to go back to your little rap. You have to know what kind of lines create the circumcenter, and you have to be able to draw those. So if you think about our rap, it's people be crazy. That stands for the perpendicular bisectors create the circumcenter. So basically what we need to do is we need to find the perpendicular bisectors. All three of your perpendicular bisectors are going to intersect at the same spot. So as long as you can find 2 of them, then you know where that intersection is at. So what I'm going to do is I'm going to find the perpendicular bisector of side BC first. So I'm going to count the whole length, 1, 2, 3, 4, 5, 6. The whole length of BC is 6. If I want to bisect that or cut that in half, half the distance would be 3. And then perpendicular to a horizontal line would be a vertical line. So I'm going to draw this perpendicular bisector for side BC. Alright, now I'm going to do the same thing for side AB. I'm going to start off by counting the total length. 1, 2, 3, 4, 5, 6, 7, 8. Since the whole thing is 8 units long, if I want to bisect it, I would need to go 4 units, because that's half of 8. And then I need to draw a perpendicular line through that, and a perpendicular line to a vertical line is a horizontal line. Now finding the perpendicular bisector of AC would be a little bit more complicated, but we don't have to do it, because once we have the intersection point of 2 of them, we know where the circumcenter is at. So the circumcenter is located at the intersection of the perpendicular bisectors, which just happens to be at point 2, 1. So that is your correct answer. Alright, so now we have angle bisectors. And remember, angle bisectors create the in-center. If you go back to your rap, people be crazy, a bit insane. That a bit insane tells you that angle bisectors create the in-center. So I'm going to go ahead and make myself a note of that. And then I'm going to start labeling what they give me. They tell me that CF is 8. They tell me that CD is 17. And then they want to know the length of DE. So ultimately we're trying to find DE. But we can't jump straight to DE because that doesn't give us a right triangle. We don't know what to do there. Let me go back and pull the picture of this real quick. Okay, so I wanted to show you this picture again because when you find the in-center, that is the center of the circle that's inside the triangle. So notice these lines right here would all be the radii of that circle. And anytime you have a circle, all the radii equal the same thing. So let me go back up to our picture and show you where those radii are at. So this would be one of, here's our inscribed circle. That's pretty rough, but that's about where it's at. So each of these red lines is a radius of the circle, meaning all of those are going to have the same length. The reason that helps us is because we can now create this right triangle and solve for DF. And DF isn't ultimately what we want, but DF has to equal DE because those are both radii of the same circle. So we're going to go ahead and use Pythagorean theorem to solve this blue triangle. Now remember, the C is the hypotenuse, which is across from the 90-degree angle. So in this case, C is 17. So I'm going to say a squared plus 8 squared equals 17 squared. And then I'm going to start doing some calculating. And then I'm going to solve for a, so I'm going to subtract 64 from each side. And then to get a by itself, I have to square root it because squares and square roots are opposites. They cancel. And so a is 15, which I let df be a. So now that I know df is 15, I also know that de is 15, and for that matter, dg, because all of those are radii of the inscribed circle. So our final answer here is 15. Okay, this is the last one. It says, which point is the in-center of triangle ABC? So I'm going to go back to my rap. People be crazy, a bit insane. A bit insane tells me that the angle bisectors create that in-center. So I'm basically going to look for and highlight any of the angle bisectors I see. So notice here, if we start at angle C, this is the line that cuts that angle in half. So I'm going to highlight that angle bisector. Then I'm going to look at angle A and I'm going to say, okay, which line cuts that angle in half? And it's this line right here. And then I'm going to go over here to angle B and I'm going to, again, highlight the angle or the line that's cutting the angle in half. Those are my 3 angle bisectors, and where they meet is going to be the incenter. So that is why the incenter is located at point D. All right, good luck on your quiz.